What's going on, people? In this series, I want to go through the technical details of the biggest smart contract hacks. So if you go on Rec News, which is basically just a newsletter that shows you the biggest smart contract hacks, if you go on the leaderboard, you can basically see how much money's been lost: 600 million, 600 million, 600 million. So over these past couple of years, multiple $1 billion in funds have been hacked. I think what's crazy about all this is that the technical details behind these attacks are actually not that complicated. And I actually want to go through in this series basically from a step-by-step process how exactly these hacks happen. So to make this really realistic, what we're going to do is we're going to fork the Ethereum chain state at that exact moment in time, and we're going to deploy an attacker contract that actually exploits these protocols as if we were the hacker. And I think that's a very realistic way to understand what happened, is to actually put yourself in the attacker's shoes, because this is exactly what they did. And I think by doing this, we can get a really good idea about what Web3 security looks like. So we're going to start with the simple one, and that's going to be Temple DAO. And what's crazy is this one was pretty simple, but it's still $2.3 million that were lost. And this happened last month. If you're watching this now, it's in November. So these things are still happening, and I think that until we get a really good idea what secure code looks like, these things aren't going to stop. So I think these hacks are still going to keep happening because the sophistication of DeFi protocols keep getting more complicated, and new people are entering the space. So I think it's a really valuable skill to have right now, and I also think it's just super interesting. Temple DAO, what happened here? So $2.3 million lost. I'm low on hope. Hack was worrying simple, and some function didn't have some parameter that was valid or whatever. All right, we're gonna figure this out. So what we're going to actually do is we're going to recreate this using Foundry. Now, Foundry is one of these newest blockchain frameworks for Ethereum, and it's actually pretty cool. I've been playing around with it recently. And one thing that I really like about Foundry is it allows you to fork Ethereum's chain state at a certain point in time. So with this command that we're going to be using to actually run our test, we can specify a block number. So if we actually look at when this attack happened, so let's see, one of these tabs, there it is. It happened in this block right here. So this was the point in time at which this attack happened. We can actually mimic the Ethereum blockchain state at that exact moment in time, and we can actually interact with the contract that was deployed at this point in time. So we're basically recreating the exact scenario. So I think it's super cool that we can do this, and that's kind of why I like Foundry. I think you can do this in other frameworks, but Foundry has a bunch of other cool stuff, so we're going to be using that. Anyways, what you're going to also need is an RPC URL. So I've set it as an environment variable. But if you go to Alchemy, you can sign up and then click this button, and it'll give you a key. And you just want to copy the HTTPS URL, and then you want to just, using this, set it as an environment variable, and then you can access it like that. Now, I'm doing it just like that because I don't want to expose that, because then people might just spam my URL. But yeah, that's basically how you do it. It's super easy. Alchemy's free, and you can just get started in like 5 minutes. All right, so we're gonna reproduce this hack. So what you're gonna have to do first is download a bunch of dependencies, but I already have that in this repository, and this is hosted on GitHub. So you can just clone this and then get started. So, and yeah, the GitHub will be in the description. We're gonna actually see what this contract was. So let's figure out the attacker contract. So this specific function did not contain any checks. So let's go to this contract, and let's go to migrate stake and see what check it doesn't have. Migrate stake. So it performs this operation, and then it also calls this apply stake. So if we go to function apply stake, looks like someone's balancing is increasing. So whoever this for parameter is, their balance is going to increase. So this obviously wants some level of access control, or else people could just increase their own balances, and that would make the token pretty worthless. So if we actually look at this function, migrate stake, this function right here, migrate withdraw, actually has a form of access control, only migrator. And this is kind of like an only owner modifier. So at first glance, it looks like, hey, this function is access control. Why can this be hacked? But the reason why this is actually vulnerable is because this parameter right here means that you can specify any contract. So this is not restricting it to this contract in general. Now, I think that was the contract's intention. It wanted to see that, hey, the old staking address is the current implementation of this contract, but you can pass in any parameter here. So as long if you deploy your own contract and then you implement this method, then you can actually this function will actually just call your own contract. No access control is going to happen, and then it's just going to increase your balance, the message.sender, who's you, however amount you specify. So let's see what that actually looks like in code. All right, so recall that we actually want to replicate what the chain looked like at that point in time. So here was the block number, this. So what we're actually going to do is, like we said, we're going to run our tests on this specific block number. So in order to actually get the contract at that point in time, we need to, so this was the exploit contract, we need to take this address right here and paste it here. But we also need to understand, so in order to call methods on this contract, it needs an interface as to what methods can be called on it. So we need to create an interface that describes every method that exists on this contract. So how we do that is we go to the ABI right here, and we can just go to this site and paste the ABI here. Whoops. And then it'll actually generate an interface for us that we can copy here. And then when we import it in our test, and then we make our contract of type of this interface, we can call any method that existed on the contract. So we do that, we get the interface, we get the actual address from the contract, which is this D286, and we run the setup function. So this setup function, it actually gets run before the tests actually start, and it's kind of like a constructor. So first, well, let's actually look at our exploit contract. So basically what the issue was that our, oops, let's get, there we go. Our migrate stake did not have any access control as to which old staking address we were supplying. So in that case, this can just do whatever. We can give it our own contract address, and then this will just increase our balances by that amount. So if we actually create our own contract with just that adheres to that interface of migrate withdraw that requires an address and a U256 amount, then we can actually supply that to our exploit function. So what we're going to do is we're going to deploy this contract and in our constructor, and then when we actually run this function test execute hack, which is going to run when we run the test command, it's going to first set our address, so message.sender to 3, and it's going to print the balance of the address of 3, which is going to be 0. Then it's going to migrate stake. So basically if we trace this control flow, it's going to run this method, old staking, which is the address of our exploit contract, which is this right here. And it's going to call migrate withdraw on that, which just does nothing. And then it's going to be done with that, and then it's actually going to call function apply stake, which, as we recall, increases our balances. So then we're going to print our balance after the stake, and we're going to see that it's super high, as we just saw. So let's see, 0, and then after the execution, we have a lot more coins than when we started. So this is basically how this guy was able to exploit this protocol. And yeah, in just those 6 lines of code, which is literally just calling this function of that contract we deployed, maybe 4 lines of code, we showed how $2.3 million got stolen, which is kind of what I was going back to the point earlier of, you would think that the complexity of these hacks would be super crazy for the amount of money lost, but it's actually not. Now this one is a lot simpler than what we usually see. There's actually some that do get a little bit more sophisticated, but I think this is a good one to start with and get a glimpse as to what is kind of happening here. Now I know some things might be unclear in my explanation, or I didn't go over exactly everything, but just clone the GitHub repo, play around with it, and you'll probably get a better idea of what's actually happening here. And in the later videos, I'll probably be able to explain this a lot better. we'll probably try to increase the production quality. But yeah, I just kind of wanted to give a rundown about what we're going to be doing this series, and then an example of that.